Okay guys, welcome back. So this is video number 19 in this series where I'm using RStudio to conduct data science tasks and data analysis tasks. So in this video what I'm going to do is demonstrate how to create density plots in RStudio using ggplot. So density plots, or KDE plots, kernel density estimator plots, as you sometimes hear them referred to, are really good in the sense that they provide a visual representation of the distribution of scores on a variable using a continuous scale. So they kind of use a continuous estimation of the shape of the distribution. Unlike histograms, where the bin size you select for the different columns can influence the appearance of the distribution of scores and how the plot looks. Density plots, I prefer them because I think they can provide a clearer impression of the actual shape of the distribution of a variable. So we've kind of seen these in the previous video. They were each leaf really of the violin plot, each half of the violin plot was a kernel density estimate, or a density plot essentially on its side. But what I'll do in this video is I demonstrate how to create a density plot nice and easy using ggplot, like most other things are, and I'll kind of show you, I'll make a comparison between a density plot and a histogram, so we can just get some understanding of where I think these might be a bit more useful. So the first thing to do is kind of load the tidyverse library from your library. So load that tidyverse package. I don't need to do it because I'm recording this straight after another video and I've already got tidyverse loaded, so I'm not actually going to execute that line of code. But if I then run this next command, if I do data, do control and run that, you can see it gives us this pop-up of all the different data sets. We've seen this before. It's kind of a good way to find data that might be useful. I'm going to just use exactly the same data set and pretty much the same code as we used for the video on histograms, but rather than create a histogram, I'm just going to create a density plot, and we use the msleep data for that. So if I do question msleep, it'll give us some information about the msleep data in the help viewer there. So remember, this is data on sleep data from different species of mammals, 83 rows, 11 variables, kind of the name of the species, whether it's a carnivore, omnivore, herbivore, how much time it spends asleep, that type of thing. So pretty good, all quite interesting. If I do the view command on msleep, you've seen this before as well. I'm just kind of repeating stuff I've done. It gives us our data set, our msleep data set. It's a built-in data set. It gives us it in this top left panel, and it looks like a nice neat data frame, kind of spreadsheet style. Okay, so rows and columns for variables. All right, so let's go back to the data frame, to the actual script, sorry. So what I'm going to do is, first off, I'm going to create a nice simple density plot, and I'm going to use ggplot. I've used the old, I'm not using the pipe operator for this first one. I'm just going to kind of be explicit with the arguments, just kind of repeating things I've said previously, but it kind of sometimes the message is worth repeating. So I'm calling the ggplot function and telling it the data I want to use is msleep. Let me not mess up my code. Is msleep, comma, mapping. So the mapping is what I'm putting on the different axes. I'm saying the aesthetics to use. There's only one in this case because we're just plotting the distribution of scores on one variable, and that is awake. That is a numeric variable, how many hours a species is awake, or how many hours these different mammal species are awake. So it's just going to count up how many times different species are awake, 8 hours, 5 hours, 6 hours, that type of thing. And then this time, rather than geom histogram, I'm specifying geom density, and I'm giving it a particular fill color, quite a nice fancy red color. It might be a bit garish, but let's see. If we run that, there we go, we can see a nice, very bright plot, but it's given us kind of awake is our variable on x-axis, so you can see the density. So we're looking at, by the looks of this, a lot of mammal species are awake between like 12 and 15 hours of the day. Okay, so that's pretty straightforward, I think. I'm going to do the same thing though, or slightly different. I'm going to add some labels to make it look a bit tidier, but I'm going to now do a histogram of that same variable, and then we'll do a density plot and compare the two, so you can see why one is potentially better than the other. So I'm using the pipe operator from the tidyverse to do this. So I'm specifying the data first, then I'm piping that into the ggplot call, and the mapping we're using, our aesthetics is the same as previously. We're just using our x variable, which is hours of awake, hours that various mammal species are awake. It's just going to count up the different how many species are awake 8 hours, how many awake 5 hours, etc. But this time the geometry I'm using is histogram rather than density. And I've added some nice labels just to make it look tidy, apart from a y-axis label, just so the plots we've got a bit of space for them. But there you can see that's the histogram with a bin width set to 2. So I guess you could tell if we go back and look at that previous plot, it sort of looks similar in the sense you've got this peak around 12 to 15 hours. But let's do the same thing though, exactly the same plot, only I'll color it. Yeah, it's the same color in fact. Same syntax, pipe operator in and ggplot from the tidyverse. And if I run them, you can see the difference between the two. So that's the density plot, and that is the actual histogram. So I think you in this case we've used kind of sensible bin width of 2, but if you change that, or let's run that again, but we'll take out the bin width argument. It might look quite different. So let's run that. Let's code cell above. There you go. So that looks quite messy, and it's picked a default bin width, and you can get the general pattern, but you can see there's a lot of places where there are no values. So personally, I think using density plots is a much better way to not lose information about the distribution of scores on a variable. Okay, that's it. That's all I'm going to say on this particular one. Thank you for watching and listening.